Let's talk about identity and inverse matrices. Every identity matrix is square. That's what the n by n signifies. So for every square identity matrix, it is a matrix that has ones on the main diagonal and zeros everywhere else. Here's a 2 by 2 identity matrix, a 3 by 3, and you're starting to see ones on the main diagonal, zeros everywhere else, 4 by 4 identity, and so on. Identity matrix has some unique properties. If you have a random matrix A and an identity matrix of the same dimensions, so that means they're both square and they have the same dimensions, these things are always true. You can multiply any square matrix by the identity matrix of the same size, and the result is the original matrix. It's like multiplying by 1 with real numbers. The other property says that you can multiply any square matrix times its inverse. That's what this notation means. Any matrix times its inverse, and the result will be the identity matrix. And we'll experiment with that a little bit more tomorrow. So here's the formula for a 2 by 2 matrix. First of all, the determinant of the original matrix cannot be 0. If it is 0, then the inverse doesn't even exist. Because the formula starts off with a scalar, and in the denominator of that scalar is the determinant of the original matrix. And you can't divide by 0. Also, what happens for the inverse is that we swap the elements that were on the main diagonal. They just change position. And the elements that are on the other diagonal, we change their sign. If they were positive, they become negative. If they were negative, they become positive. Let's look at an example. Start by finding the determinant of the matrix. Multiply diagonals and subtract. 6 minus 4 is 2. That means the inverse starts off with a scalar of 1/2. We swap the 2 and 3, and we make the 1 and 4 both negative. And to finish this up, we just multiply by the scalar. That's our inverse. Let's do one more example. Go ahead and pause the video if you feel ready, and press play to see the result. We're going to find the determinant. -12 minus a -8 is -4. So my inverse starts off with a scalar of -1/4. We switch the 6 and -2, and we make the 1 negative and the 8 positive. Last step, multiply through by the scalar. And always simplify fractions where you can. Like I said, we'll do more with inverse in upcoming lessons.